today's homework is going to be about these questions that you might see on part 1 of your test tomorrow, Wednesday. Okay, so we give an equation. It says, what value of P would make the equation below have no solution? Why? What makes an equation have no solution? Empty set. Okay, so I remember from my notes, I take them out from lesson 105, right? This is from lesson 105. No solution means that I have to have the coefficients in variable terms the same, and the constants different. Okay, this is that table that we had in lesson 5. Okay, so here let me go ahead and write my equation first, and I need to clear it up a little bit. It looks like it needs some simplification. So I have negative px. Remember, I'm going to assign a value to p in just a bit. This side, I don't know what the variable terms, the coefficients are going to add up to, because I first need to know what they will add up here. So when I simplify this part right here, I'm going to distribute negative 2 times 5 would be negative 10x. Negative 2 times 10 would be negative 20. So now I know that my coefficient here of the variable term is negative 10, which means that over here, when I add these two together, I have to have negative 10 in order for this to be a no solution. Okay, so then that means that P must be positive 3. If I make P be 3, then I'll have a negative 10 here. So I'll put P equals 3, and then I will substitute in the 3 and try it out and make sure that I am correct. Okay, so then from there, I will have negative 10x plus 32 when I put these two together, because when there's two negatives, you add them together. So then, yes, I have negative 10 and I have negative 10. The coefficients of the variable terms are the same, and the constants are different. Okay? So that is a no solution problem. So now I have to explain why and what makes an equation have no solution. Okay, so here I'll put when coefficients, so I choose first a value of P. P should be 3. Because, okay, when the coefficients in variable terms are the same on both sides. I'll put in this case negative 10. Okay, they will cancel out. The constants on each side will be different. Okay, in this case, 32 equals negative 20 is a false statement. So there's no solution. Or you can say it's a contradiction, so there's no solution. Okay, so something like that, or you can put in your own words as well. So here, if I make P equal 3, okay, the negative is already there, but 3 positive, it would make it over here negative 10 and a negative 10. Those would cancel out, and you can show that if you wish. Okay, you must simplify it, but you can also show that these would cancel out, and you we're left with that false statement that we refer to right here. Okay, which means in their solution. Alright, for number 2, is there a value of P that can make the equation above have infinitely many solutions and identity? Why or why not? So, I need to know my definition of this first in order for me to answer that question. So for infinitely many solutions, I know that the coefficients of the variable terms and the constants must be the same. Okay, so coefficients and constants the same. Okay, that's what I remember from here. So I have my equation. I did in number 1 make the coefficients of the variable terms the same, so I could say if P equals 3, right, I had that negative 3x plus 32 minus 7x. I'm just copying what I did on the top, right, and so here I would have the negative 10x plus 32 and the negative 10x minus 20. So I successfully changed those, but in order for me to have an identity, these would have to be the same. Okay, and remember P, it was just this. I changed this to 3. So changing the P right here would only change the term with the variable, in other words, a coefficient. It can only affect the negative 10. It does not affect the 32 or the negative 20. So by changing P, in other words, I cannot change the fact that the constants will still be different. And for an identity, I need them to be the same. So no, there is no way that I can make this an identity with any value of P. Okay, so I'll write that down as my answer. So I will say for infinitely, let me use maybe a darker ink so you guys can see better. So for infinitely many solutions, the coefficient of the variable terms okay, on both sides must be equal, and the constants on both sides must be equal as well. Okay? The value of P won't change the constant of 32 or negative 20. So the value of P in this case will not change the constants. Constants are different. 32 and negative 20. This cannot be an identity. Okay, so if you find in your own words that you can use the vocabulary and explain it that way, you could as well. Okay, so there's no way that by changing P right here, that coefficient right here, it will not change the constants. And since we need them both to be the same, this cannot be an identity. Okay? On the bottom, it says that which of the following is an identity, which one has no solution, and which one's a unique solution. Okay, so actually there's one missing, so there's two that are the same and one that is different. So here, when I simplify this right here, let me zoom in here. Okay, I will first distribute the 1/2. So I'll have 2x plus 3, right, this stays the same. And then 1/2 times 4x would give me 2x. 1/2 times 20 positive would give me 10. Okay, I'll combine the like terms. So I'll have 4x plus 13. Okay, here I notice that my coefficients of the variable terms are the same, and also the constants are the same. So then this is an identity. Okay, and this would be infinitely many solutions. We can say also all real numbers. Okay? For the next one, I'll do the same process. I will first distribute, in this case, the 5. So 5 times x would give me 5x. 5 times 9 would give me 45 positive. I'll combine the like terms. Here I don't have the like terms, but here I do. Here I notice the same thing. Okay, so the variable terms have the same coefficient, and the constants are also the same. So this is also an identity. Infinitely many solutions. Okay, are all real numbers, which can also be like this. Okay. The next one, I'll start with also by distributing that 3. That 7 stays there. The 3 I will distribute. So 3 times negative 3 would be negative 9x. 3 times positive 10 would be 30. Now I'll combine like terms on both sides. Okay, then I'll bring all the variable terms together and all the constant terms together. So I'll move this one over. They cancel out here, I show that. And here will be this, minus 7, to bring all the constants to one side. And then finally, I'll divide by 27 to isolate the x. Okay, so I have 30 over 27. If I divide them by 3, I will get 10 over 9. If I divide by 3. So that's a perfectly good answer. X equals 10 over 9. It's already simplified, so this one has a unique solution. Okay? Alright, so let's turn the paper over. Here I have to solve the equation for W. Here's W, so I'll write it over again. And this will give it an exit ticket. So I have to isolate the W. I'll get rid of this addition first, so minus 2L on both sides. And I'll get P minus 2L equals 2. Between the 2 and the W, it is a multiplication, so to undo it, I will do division. So if I multiply by 2 and W together, I will divide by 2 in order to isolate the W. So W equals P minus 2L divided by 2. This one I'll write it again. I am solving for B here, in this formula for area of the triangle. Okay, so here the B is being multiplied by h and also divided by 2, right? Because times 1/2 is the same thing as divided by 2. So I'll get rid of the divide by 2 first by multiplying by 2 on both sides. When I do that, those two cancel out, right? Divide by 2 and times 2 are inverses, so they're gone. So I'll have base times height. I'm still looking for the base. And then over here I'll have 2a. Okay, so now base is being multiplied by height. So to get rid of that multiplication, I'll do the inverse, which is division. So I'll divide by h, and I'll divide by h. So now b will equal 2a divided by h. Right, so then in the bottom, we're supposed to match each inequality to the graph. Okay, so I'll start with A. and I can do it here in this space. I'll start with plus 8. Right, to isolate the x, I get rid of the minus 8 by doing plus 8, the inverse. I'm left with 6x. Okay, this will be negative 18, and this will be 24. Okay, so I still need to isolate the x, so I'll divide by 6, and I'll do that to all sides. Okay, and then I'll have, over here, I will have negative 3, x, and 4. Okay, I left the signs as they are because I divided by a positive, not a negative, so this stays. So this, because it's in the middle, this is an and inequality, so I'm either looking for this one or that one. Okay, so it's between negative 3 and 4, between negative 3 and 4. This one too, but these have open circles. This has open circles, so this must be A. Right, I'll do B here on the side. So maybe B over here. Okay, so for B, I will first get rid of that divided by 3 here to isolate the x. So I'll do times 3 on all sides. Those cancel out, that's the inverse. These also cancel out, right? Divided by 3 and times 3 are inverses. So I'll have x plus 2, and then 6 over here. I still have to isolate the x further by minus 2. That is the inverse, cancels out. That's negative 3, and that's positive 4. I didn't divide or multiply by a negative, so this will be letter B. Both are included, 3 and 4, so this bottom one between 3 and 4 included would be letter B. Okay, so now I'll do letter C. Letter C is an or inequality, so we'll start with the first one. Okay, so minus 1 on both sides to isolate the x, and then divided by 4. I divided by a positive, so the sign stays. Okay, so that's my first inequality. And then the second one is, for C is this. Okay, so plus 5 on both sides to get rid of that. Okay, and this will be positive 2. To isolate the x, I have divided by 2, so the inverse will be times 2. So I'll do that to that side too. So x is greater than 4. So for letter C, I'm looking for these two, x is less than 3 and x is greater than 4. And they're both open circles. So over here I have x is less than 3, an open circle, and greater than 4, open circle. So it looks like this is C. And I'll still do D, but obviously this would be D. Okay, so for letter D, I would first multiply by 3 to do the inverse of that. And that would be negative 9 plus 6 plus 6. X is less than or equal to negative 3. So that's that. Okay, so it matches. And then the other inequality for D would be this one. Okay, minus 8, the inverse of plus 8 to get rid of that and isolate the x. Okay, and here would be 8 divided by 2. I'm divided by a positive, so I leave it as is. X is greater than or equal to 4, and then this one's x are greater than or equal to 4, so it matches. So there you go. Okay, I hope you study this, and good luck on tomorrow's test.